This is the Amp Hour Podcast. Released August 19th, 2019. Episode 455. Bill and Dave's Excellent Equipment.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Back with the same intro we've been doing for a decade.
Not a decade. I was actually thinking I think we hit our I think August 10th was our anniversary. So happy 9 years. We're entering our 10th year.
Right.
Yeah.
Yes.
Started in 2010. So
yep.
The 10th year of the Amp Hour commences, and we're sorry.
Yeah, that's about all we can say.
We'll try harder next decade.
Right.
Well, let's ask what's new then. What's new with you, Dave?
What's new with me?
Yeah,
There's not much new with me.
I don't know.
We can talk about my latest video, if you like.
Sure.
Yeah. Why don't we start?
Why don't we start with that? I've got some things to talk about, but yeah, I think let's start with the debacle. So this is the multimeter.
This is the Vion multimeter. For those who aren't aware, it was a Kickstarter and Indiegogo, because you've got to have two sucks of the sav these days. Right?
Of course.
Nobody just goes on one platform anymore. It's always
right,
dual platform, usually at the same time. You know, Anyway, it's a thing. So they raised over $500,000 Yankee bucks, I think, for this little dinky multimeter. It looks like two probes, basically, with a curly cord between them, and it's a Bluetooth multimeter that hooks up to your phone. You know, it doesn't do much unless you hook it up to your phone. It's got some LEDs in the tip of it to light up red, green, and blue and stuff to show you various statuses of things. But apart from that, yeah, you got to hook it up to your phone app. And they promised everything. Oh my God.
Yeah.
And the worst part is they promised like a shopping cart experience, so that if you test a light bulb or a fuse and it's blowing, it'd automatically order you a new part.
Okay.
Instantly you can kind of start seeing the problem with that.
It's a marketplace. It's a marketplace.
It's just unbelievable. For those whose brains aren't engaged at the moment because you're listening to the Amp Hour, what that means is that, well, they're probably on their exercise bike, or walking the dog or whatever, not just, spacing out, listening to the Amp Hour.
Sure.
Who the hell wants to engage their brain? It takes energy.
Right.
Anyway, let us analyze it for you. Obviously, you have to know exactly the type, rating, and all the specs of the product that you need, that you're actually testing first. So what's the point, like, having a shopping cart thing that can just... Anyway, so dumb. And they promised it was like the world's easiest multimeter, so that anyone can use it, of course. And it just like people who know nothing about multimeters can use this thing. Right, and you'd never have to call a repairman again, because you'd be able to fix stuff yourself, because you'd be able to test that something's broken and then automatically order it on your shopping cart to come, and you just replace it, and you don't. Oh God, it's that bad.
Okay, so
anyway,
that's a bad business model, but that's not a bad multimeter necessarily. So
no,
keep going.
not okay. Yeah. Anyway, it actually took them a year, so they're more than a year and a quarter later, so which is not a problem, right? These things happen. And they were really good in their updates, actually. They were, posting photos, and they got bad parts from AliExpress, and
Well, of course,
it's like shock horror, right? So they were really good at all the updating and everything, and they kept having excuses. People said scam, but they were posting. It was obvious that they weren't scamming. They were doing real hard work to get this thing to market. So hats off to them, right? And anyway, they finally shipped. But before they shipped, they did this update that said, oh, look, we're great news, we're about to ship, and sort of like in the small print at the bottom said, oh, by the way, the capacitance mode doesn't work, the inductor mode doesn't work, the voltage output mode doesn't work, we couldn't get that working, the app is buggy, it doesn't really work properly, we'll needs another
month. It's not really a multimeter, it doesn't really do anything.
It doesn't really do anything, but we're going to ship it anyway. Yay. and everyone started shouting, refund, and they actually offered refunds. But I haven't heard that anyone's actually gotten a refund yet. So I'm not sure what the deal is there, but they did actually offer it. But anyway, they started shipping all these things out, and somebody sent me one, so it turned up in the mailbag. So I decided to do this video on it, and as always, there's a big thread over on the EEV blog forum called The World's Silliest Multimeter, because the concept and the app just looks so silly. It was just all the stuff they were trying to do with it. It was just dumb. But like you said, right, it's like, yeah, they'd eventually find out that all the stuff they were trying to do is dumb, but it could have been a potentially useful USB multimeter for want of, I mean, it's not, I'm not going to write home to my mum about it, right, but it could have worked. Anyway, I got one, and like...
So the idea is like that it's Bluetooth, okay, so that's not bad.
It's Bluetooth only, yeah.
Yeah, so what's her name? Mushimeter did that, right? We had Eric on the show.
Yes, that was
James
one of the first. There's the PoKit one, which was another Kickstarter successful one done by a company here in Sydney, which used to be David Two's former employer, actually.
Oh, okay, yeah. I mean, and the concept isn't bad. I mean, like the idea of a wireless multimeter.
It's not necessarily bad. There's a niche market for it. Like it's totally, not going to set the world on fire, right? So. Yeah.
Right, but I like the idea of like the voltage isolation and basically having streaming capabilities. You could be isolated. You could actually be like physically isolated from, like I remember they showed it like within a test chamber on the other side of like
right. Yep. Of course.
When they were measuring what's it called, Tesla coils, stuff like that. You're far away.
Yep. Of course.
You're safe.
Yeah.
Oh, so I like that idea.
Inside. Yeah. Yep. Okay. Absolutely. But this wasn't really designed for that. No, this was designed for Joe Average to, test things. I guess test things around their home,
At the end of the day, I'm wondering, like, who's going... Are people, like, browsing Kickstarter and Indiegogo still? Or is it, like, they're getting sucked up into, like ad campaigns?
No, they do. People browse the tech categories. They just sit there all day browsing. There's these super backers who back hundreds and hundreds of projects. And obviously they're just, and I've talked to a few of them. I know a couple of super backers, and they say, I just browse the thing, and anything that sounds interesting, I just want to, sometimes they'll like just buy in for $1, right? I know a few people who bought into this Vion, even though they knew like it wasn't going to do what they claimed, they bought in for $1 just so that they could follow the saga. Right.
Yeah, they're like looky-loos, but you have to pay the ticket in order to get through the gate.
You have to pay the $1 or $5 or whatever the minimum buy-in is to follow the
That's interesting.
Hilarity just in case they do the private updates and stuff like that. Anyway,
I feel like there's that's like the potential for like a stronger community, and obviously a lot of people are great with like backing Patreon and of like different channels and stuff like that, but like it just feels like wasted energy, like,
yeah, I know. It's but people just love their tech gadgets, and they just and granted, Kickstarter's a place to find new. I'm going to put innovative in quote marks, right? Because we don't need another 3D printer, It's like, but or another cooler or another,
Yeah, the coolest cooler.
The coolest cooler, but like people just love their tech stuff, so they just browse. And maybe you can get, I don't know, I've never tried. Can you get like email alerts from Kickstarter and Indiegogo about new programs? Maybe. Yeah, anyway, that's where a ton of people come from.
Yeah, I was wondering, I had this discussion with someone recently, I forget who, but I was trying to estimate it was someone who actually makes dev boards. That's what it was. And I was kind of asking like, well, what percentage of the boards that are kind of like that are ordered, right? At the beginning of a project, you see a flashy video and you see like, oh, this is all the things you could do with this thing. What percentage are actually using them? Because I know I have a box. I literally have a box
I know.
of dev boards, right?
Here.
And and some are back the campaigns. Some of them are just, oh, that looks interesting. It's like the story that I told myself was like, oh, I'll definitely use this for something. But like, of course not, you know, like
No, that's
just
right.
from a practical perspective, like I can't use every platform. I can't, it's stupid to do that and keep trying these things. Anyways, like, so what is the percentage of like utilization of dev boards? And then I said it, you know, the extreme example would be like, I think Raspberry Pi is at like 25, 30 million boards sold at this point.
Yep.
How many are actually in like active use on a daily basis?
I would be stunned if it's 10%.
I
would be stunned if it's reaching double
1%.
digits. Really? Yeah. I
Yeah.
wouldn't argue with that. Yeah. Yep.
Just because I think about like, okay, so like 10%. So like, let's use 10 million. That's an easy number, even though I know it's more, right?
Yeah.
So that would then mean like, so 10% of that would be 1 million. 1% would be 100,000. Like 100,000 people using a Raspberry Pi every day? Maybe. I don't know.
Yeah, maybe. Yeah.
I guess
I
you'd have
can
to multiply
see
that
that.
by 4 or whatever they've sold all told.
Yeah.
But
Yeah.
yeah. Yeah. It's just an interesting thing. I just feel like a lot of dev boards and projects and stuff like that are supported, and like, you know, God bless them, because that props up the people who are using it.
That's
you know,
right.
and
it makes
but,
these
like,
things
how many are
actually exist
used?
for when you do need them.
Yeah.
I mean, just imagine if we
Right,
didn't have
right.
the ecosystem of dev boards that we have now.
Sure.
That you actually
sure,
take
sure,
for
sure.
granted. Now,
Yeah.
like if you want to get a job done, right? There's a dev board or a, you know, some sort of module out there to do it.
Yeah. Oh,
It's
yeah.
great.
It really.
Whereas when
Yeah,
I was
as
a
a
boy,
consultant now, it definitely has
it makes
saved my
your
bacon a
life
couple times.
exactly.
Yeah. Yeah.
Yeah, but it's
Right. Well, and I
obviously
think-
depending on the product. Dev boards are like that, but something like a multimeter is like, it's a tool that you can use daily.
Sure,
So
sure.
you know, it's much greater usage.
Yeah, yeah. Well, and I think that what that points to is that like in any of these projects where you're doing crowdfunding or anything like that, you know, it can't just be like, hey, here are the raw specs. It has to also be like, you know, here's the project you could do with it. Even, you know,
Oh,
even if
yes,
it's kind of
I know.
contrived, it's like, yeah, you know, so it's like
Yep.
you have another microcontroller platform. Yeah, you could do a lot of things with it, but you still need to show a couple things that you did do with it, an actual actual like end products or projects rather, so that people are like, I want to do that thing, you know, like
Exactly. Or I might
yeah,
need to do that
yeah.
thing, or I better have it in my toolkit.
yeah, right.
Just in case, you know.
I don't know
Yep.
when I need to set up 1,000 tap for a filter. You know, I might
Yep,
need
that
to.
there,
Dave.
that's
like,
right.
You know,
Never know.
I should have that you know, Xilinx Zinc dev board. You know, I need to pay
That's
$200 for this right now. Yeah. I may have had this conversation in my head before.
Well, you shouldn't laugh, but it
Yeah.
is kind of funny how, you know, most of them, like only single-digit percentages end up being, you know, used for anger. Like,
I mean,
like
it's-
people usually get it and then power on and have a fiddle with the app that comes out of the box. I'd say, you know,
Yeah.
probably more than half would be doing that, right? But after that, it's
Sure,
like, oh yeah,
sure.
yeah, it works. LEDs light up. Yep. Got
Yep,
my
yep,
warm,
no.
fuzzy feeling knowing that I
Check,
backed
check,
this
check.
project and it turned up. Yep.
Yeah.
But in the case of the Vion, it's like there
Not so much.
nobody. This is going straight in the bin as soon as people got it. There are people who have paid for it, and it's come into their country, and they've got, you know, it's stuck in customs or whatever. So they've got to pay, you know, an extra $20 to get it through customs in these pain in the ass countries, right? And all you see in the comments is, nope, I didn't even bother. I didn't even bother paying it. It's just, no, I'm not going to spend any more money on this. It's like
Yeah.
just based on their own updates of the
Yeah.
thing, let alone when my review hits the airwaves, you know.
Yeah.
So,
Right.
oh boy, yep.
That's funny.
Anyway, yeah, like there was like nothing on it that was like nothing on it that was. I think the only thing I actually commended was that it was a reasonably fast update rate. That was it. Like everything else
Okay.
either didn't work or was flawed or was, you know, oh my, like wow.
Yeah.
It's so unfortunately, like the
Shonky, huh?
hardware, it might have been useful, you know, if the app was perfect, but the app was just absolute garbage. So yeah,
That's too bad.
unfortunately, the app makes the product. So
Right,
Yeah.
right.
And anyway,
Well, that's something
one
that
of the
could be
funny
updated,
things,
but it's not necessarily going to be.
it could be. It's not going to be. No. Unless somebody reverse engineers the whole thing and then just does their own from scratch. Nobody's going to
Right,
bother because the hardware's not that great anyway. And one of the funniest things is like it's the world's simplest multimeter, right? But the app has this sensitivity button that you can sensitivity plus minus. It doesn't explain what it does, and if you hit it, it can give you completely wrong values. I'm talking like 5 volts from a 9-volt battery or 10.5 volts from a 9-volt battery. Like, wow.
It's if the precision, the digits of precision, go the wrong direction there.
Yeah.
Just rounding
actually,
up or rounding down.
From a technical point of view, though, right? This is actually a real interesting example of where they're completely kamikaze because they didn't use a multimeter chipset in the front end, right? They've just got a microcontroller on there. It's one of those Bluetoothy, ARM micro, integrated things. So presumably
like an NRF
uses
chip
the
or
built-in.
something.
Yep. Yes. I think it's one of those. And it's got to be built-in analog to digital converters or whatnot. And so they're using all that. So they're doing all their own switching and so there's a bunch of transistors on there that just switch in the various loads and configurations for the different functionality, right? Whether or not it's measuring resistance, it's measuring voltage, AC or DC, and so they rolled all that themselves. And I'm not sure if you've seen inside the data sheet of a multimeter chipset, but they're even like a $2 multimeter, right? They are incredibly complex. There's so much going on to make and to give a multimeter its functionality, especially its auto ranging functionality and all the different modes that a multimeter, in quote marks, can actually do. And it's that. But they chose, we'll just use a microcontroller with an ADC, which is okay, fine, but you got to know what the hell you're doing. And
Sure.
they've completely
So I haven't seen
kamikaze.
the chipset, but I've seen the what it takes to actually have a device do that. When I used to work at a test and measurement company, basically it was the more complicated version of what they were trying to do, and it's like no, that was like a huge software stack to get all those things doing, and then you have to have all the switching right, you have to have all the timing right, and the capacitance on your gate set up so that you're switching at the right time too. So it's pretty.
It's nuts.
It's really important.
I just sent you a link to the one used inside the 121 GW multimeter.
Oh yeah, okay.
And if you scroll down to like page 21, right, you'll start seeing the function network of what's happening inside an example app.
Yep.
It's just
This is like a hard logic version of what was happening inside a Keithley DMM.
Inside a Keithley electrometer or something.
Yeah.
Yep. And it's like, okay, yes, you can roll your own, but no. So
but not for the low cost that you really, not in a short amount of time.
No, exactly. Yeah. And no, you just, it's hard enough to drive these things, right? Let alone you might use a multimeter chipset, but there's hundreds of registers in there that if you don't set them up right, you're going to completely kamikaze, but at least you can fix that in software, right? You fix that in firmware. But if you screw it up in hardware, you are gonski.
Yep.
So, anyway, so they had to add this sensitivity. I just thought it was hilarious that they had to add this sensitivity feature. And it's like, Joe Average is going to know what sensitivity is, and they're going to think that their 9-volt battery is giving out 5 volts. And like, wow. Anyway, complete and epic fail. We were talking about your former employer, Keithley.
We were. And you were making fun of me.
Just before the show, I was making fun of you because you just casually dropped
GPIB.
GPIB.
We called it GPIB.
GPIB. And I instantly, and my mind just rattled for a second, and I kind of got like a twitch in my neck, and it's like, what? Nobody calls it GPIB.
On the other side of the pond, they do.
If you don't know what. But apparently, you say they do at Keithley. That's
the ones that I knew there. Yeah.
Wow, really? I've never heard anyone call it GPIB. It's always GPIB.
I'd be okay with it going away. It is a old and tired standard, but it's out there still. And you had made a video about it. That's why I brought it up.
I did a recent video about an Ethernet interface. Which is
It's a good idea. I mean, like it really is.
Yep.
to have that kind of
How
thing
you
out
can
there.
network. Like, it's not good if you just want to control one instrument.
Mm-hmm.
What it's good is if you want to network like 20 different instruments in a rack.
Right.
Like if you don't know, GPIB is like a parallel multi-drop bus that you stack these cables all in parallel, all these instruments, and it can have up to 30 addresses if memory serves me correctly. So you can have up to like 30 instruments. And
It's kind of
or is
like
it
that.
20? I don't know.
Do you remember that?
Yeah.
Did you see that tweet that I forget who it was? I'm looking up on Twitter. Someone had set up like that crazy setup. Here it is. Robbie Newell on Twitter.
Is that one in there was just like 3 or 4 days
Battle
ago?
Station is armed and operational.
That was great.
Yeah,
I retweeted. That's just brilliant. That's like a research
Yeah, it was
setup. It was for
Yeah, so it was lock-in
was it
amplifiers,
doing?
and there's two superconducting magnets, and a bunch of measurements around it. We'll share the Twitter
beautiful.
thread.
It was
really
just.
was.
Did you see the pegboard they had with the like splitters and everything? So they had these
Oh no!
splitters attached to these pegboards, and then the coaxes running out of them. And rather than just have it like flapping around in the breeze, they actually went to the effort to stick it onto these panels. It's really great.
Yeah,
It was really great. Have you ever used one of those lock-in amplifiers?
No, like a Stanford Research Systems kind of thing.
Yeah. Stanford Research
'cause
lock-in amp.
I was always doing like that's like higher frequency stuff, right?
It doesn't have to be. It can be extracting. Basically, if you don't know what a lock-in amplifier is, it gives you the ability to extract your expected signal out of the noise. Like, so if you've got, they're often used in physics experiments. I won't pretend to understand why or, how, but so if you're expecting a 1 megahertz carrier to be coming back from some test thing, but it's buried in like volts of noise. You're expecting a 5 microvolt signal to come back, but it's buried in volts of noise. A lock-in amplifier can extract that signal out of ridiculously high noise. It can go down to nanovolts even, right? It can extract a signal down in the nanovolt range, like crazy stuff. So apparently it's big in the physics community. So as you can see in that photo, this is
I just
not
found
visual,
what they were
but
doing too.
we
So
can put it
further
up.
down, it says they were testing 2D crystals like graphene, multiple taps bonded, sample sandwiched between two plates, inducing a variable electric field running in the 3 helium, 4 helium dilution fridge. I assume that's the isotope.
Obviously.
And then ramping up to plus minus 18 Tesla. Oh my God.
For those who don't know, a Tesla's a pretty big unit.
That's right.
Like a farad. A farad is a pretty big unit.
Right. When you get to farads, you're really chooching there. I feel like, I look at this kind of stuff too, and I'm like, man, I just don't do anything important at all.
I know,
like
exactly.
these kind of like science experiment things, like they're too, like obviously this is well funded. It's got a lot of equipment in here too. But man, this like raw science stuff, holy shit.
Yep.
Like they really, hats off,
I've
Robbie.
done some raw research stuff, but it's not, physics research, but I've done, research on crystals and things like that. And it's fun. Like it really feels like you're really doing, real meaningful experiments. It's like, I don't think anyone's ever done this before. Wow, what are we going to discover? Kind of thing. Or maybe someone has, but it's in some obscure research paper that you can't find on the interwebs, So you've got to just run the experiments yourself and find out what happens.
Yeah.
So
I think it's the same kind of feeling like
fascinating.
when I look at like space, like older space, not even older space stuff, like space stuff too, where like people are like doing this kind of stuff, like launching stuff into space. I'm just like, I don't even where to even start,
Right.
And obviously there's tons of institutional knowledge. You would never do it as a solo person.
No, of
so
course.
you're part of a bigger team.
Like, even SpaceX, for example, they it's not like they just hired all these green engineers. No, they hired
they're leaning on
people
NASA
people
veterans.
who had done who had done self-landing rockets before. Right, because they didn't invent it. It was like, it was done in the 80s, right? So they hired a lot of these old people and they knew how to do it. And it's
Actually, I don't think I mentioned that on here before. One of my friends from co-op, he had contacted me to be on the show at one point, so I'm not going to say his name here, but and hopefully he still will be. But like one day I found out, I was like, I just kind of lost track of him, and then someone's like, hey, yeah, have you talked to him in a while? I'm like, no. He's like, yeah, did you see? Let me send you a link. They sent me a link of that grasshopper video. Remember the early Tesla, like the rocket that went up and like then hovered and landed again? And he's like, they're like, yeah, he designed the control system for that. It's like, oh my god,
sweet.
Jeez, I mean, like, yeah, people doing that kind of thing. Unsubstantiated too, but like that's the kind of thing where it's just like that's some legit things. Whoever designed that.
What the hell were we talking about?
We were talking about research, and before that,
GPIB.
GPIB.
No, we're talking
you just said it. GPIB. Yeah.
Does anyone else call it GPIB outside of Keithley? Please let us know.
Yeah, that'd be good to know.
Wow.
Yeah. I mean, the real fun thing with GPIB is when you've got like when you do have the stacks and stacks of machines kind of like network together, and you start like piling up the cables, and they're like, because like the cable itself is probably what, like, I don't know.
They're
like,
big and thick, and they're heavy, and they're
like 10 centimeters each one. I mean, or so.
Yeah,
and like
they're beasts.
They really start to stack up, and they're heavy. Yeah, the cables themselves are super heavy, and they're just industrial, old school, and they screw together because they'll fall off if you don't, because they got so much weight to them. They're not fun. I'm not a big fan, but
no.
But you said in that video too, it's a good way to get access to old gear, which is really nice.
Yes.
And if you can get it on the internet, then you can start to do more scripting. The scripting with GPIB itself is pretty rough. I mean, like if you look at the language that most of them accept, it's pretty annoying. But like then you put it into Python, you start to, or something similar. You could really start to make it a little bit easier, and get some old gear off eBay too. All that stuff can really start to help. So.
Because all that old gear, they haven't improved on the actual performance that much, right? They've just changed the UI, and they've done a few other
some of them
niceties. It's like some of them are like I've got a Keithley electrometer here, right? It's only beat by like one other, like it's like 40 years old or something. It's only beat by one other on the market, I think, and not by much. It's like, its performance is pretty kick-ass, right?
Well,
but it's...
I mean, I guess the limits of, component sourcing and stuff like that, if you're going to have like a really good resistor, it's always going to be really good, well, not always, but that, whatever the defining spec is.
Right.
But some of the silicon in there has gotten better, I think. Depends on what you're doing.
Of course. And they've gotten smaller as well. Like,
sure,
I just did a teardown of a gorgeous old HP jitter analyzer. Did you see that video?
I did not see that one, no.
Oh, you'll have to. Oh, it's gorgeous. It's gorgeous. Okay. It's got these, it's all plug-in boards, and it's huge, right? This thing today would fit on a Raspberry Pi size board, right? But it's just like you open up, and the engineering that goes into that, and the serviceability. It comes with a built-in service extender card in the slot, so you can actually lift the boards out, put it on the extender card, so that you can work on it.
Yeah.
Like,
That's nice.
Oh,
is this the one that
beautiful.
It was resistor color? Someone pointed out it was resistor color coded?
Yes.
Okay,
yes,
I saw that tweet
I did an
about
update on my second video,
Yeah.
Yep. They, if you don't know, they lay like the little handles that allow you to pull up the cards. They actually color coded those. It turns out they were in the resistor color code order.
Yeah,
black, brown, red, orange, yellow, green, blue, purple,
nice.
grey, white.
That's
that
nice.
is nice. Somebody at HP was like, "Yep, I'm doing these as as the color code."
I know how to get this done. Yeah.
Yeah.
That's great.
Oh, fantastic. And that old gear is just, it's, but it's big, and it's, power hungry, and, big fans were, and, yep.
Yeah.
Yeah. So, but anyway, they don't make them like that anymore for repairability, serviceability, things.
Yeah.
Well, they still do. In some, like, big in industrial and other markets, they do make, and military, as we'll get into, they make things repairable still, and they make them, because like space really isn't like a real huge issue for those, for things that go inside racks and stuff like that. Like size isn't really a big deal.
Right.
So you can often
Well, there's
make
always like
things
the
serviceable.
perceived sturdiness too. There is that.
Oh yes, of course. Yeah, of course. Yeah, it might be able to fit inside a little Raspberry Pi sized board, but you need to put in a big 19-inch rack to make it look,
Right.
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 Big and grunty and yeah.
I was really surprised. I was
worth the
talking
money.
to someone today about the Rigel scope that you've done a bunch of stuff on, like the upgradable one. I think the 1054, not the 1052.
The 1054Z, which is hackable. Well, they're all hackable,
that one.
but
Yeah.
Yep.
That's $200 now. That's crazy. Like,
What? It's $200 from where?
That's what my friend said.
Really?
I don't know. But like, because there's some new version that's out there, maybe it was like that was like remaining stock or something.
It's got to be a remaining stock. Wow, because that's crazy. Like $400 used to be the going price, and
Right,
it actually
exactly.
used to be $800. Right.
Right. No,
when I first got the 1052E, which was in my very first video, I actually reviewed that. My first ever video, that was $800. Then the price went to $400, like a year or two later, and then it sat at $400 forever.
Yeah.
And
I kind of put that at like the lower limit of like, an actual scope with a screen and probes and stuff like that. But maybe not.
Yeah.
Maybe and that's the thing, like, things keep getting cheaper, but there are some limits on like, you got enclosures, you got some decent chips in there. And I guess maybe this is kind of if the scope started to go towards like how the multimeters were, if there was more custom silicon that could, not custom silicon, but I guess like cheaper commoditized silicon, because everything has, silicon in it. Where like the multimeter chip you brought up, like if there was that for the scope side of things, that would be interesting to keep bringing down the cost of scopes. But I'll have to double check on that.
It's I pulled it up here. One of the cheapest prices on sale is $349. So I
on
don't know where
eBay
$200 came from.
Yeah.
Wow,
Okay.
that's like, geez, that'd be, geez, you'd just buy a spare one for that.
Right, right.
If it was 200, like you
Just
just
blow
buy
it
a
up,
second
who
one
cares?
because then you can have an 8-channel scope.
Yeah,
right.
yeah,
If
right.
it's like you would just, and that'd be a no-brainer. Geez,
Yeah.
that's just nuts.
Yeah.
Speaking about custom silicon and Rigol, that's interesting because you know how Rigol rolled their own. They're now one of the big players. They rolled their own ASIC. It took them years to do, right?
Oh, I thought they were still doing FPGA stuff.
No. They
okay.
rolled their own ASICs. They're their new 5000, 7000 series scopes. They use their new Phoenix chipset, they call it, and and they're one of the big players because they rolled their own ASIC. But if you use any of their new scopes using this new ASIC, it lacks the high-res boxcar averaging feature, which like every scope on the market has. And for some reason, it's mysteriously missing in all of the new Rigol models, and they don't want to say why. I suspect, my theory is that it's not they forgot to put it in. My theory is that they put it into the chipset and it didn't work. And because it was the ASIC and they don't want to spend the millions of dollars to remask that thing, they just went, well, we'll just switch it off and hope nobody notices. So if you do know the exact reason why Rigol's brand new scopes don't have high-res feature, then
can you explain that?
let us
Sorry,
know.
I'm not enough of a scope person to know what you're talking about.
Right. Most scopes have an 8-bit analog to digital converter, right? But you can enable a high-res mode where it does a boxcar averaging. A boxcar averaging, that's just the technical name for the averaging filter used. But it basically uses a rolling average filter after the ADC stage, like, at the sampling stage before it gets processed and everything else, as so that by averaging your samples, you can get a higher effective number of bits. So you get a cleaner waveform, right? You get a higher resolution. And some scopes, you can actually, the way they do that is in the user interface, it'll go, how many bits do you want? It's like, do you want 8 bits, which is your normal mode? Do you want 9 bits, 10 bits, 11 bits, 12 bits? Right? It doesn't have a 12-bit analog to digital converter in. It's only got an 8-bit one. But by doing the boxcar averaging on the fly, you can get an effective greater number of bits. And
do you lower your sample rate because like your effective sample rate drops then too?
You do effectively lower your, yes, you do. So,
Okay.
yep. You see, yeah, but it does like so. It's not done at the post processing
Yeah, it's not in
stage.
the GUI where you're just like doing an overlay.
It's not in the GUI where it's just doing. No, it's actually just at the output of the analog. It's inside the sampling chip,
Sure.
right?
Yeah.
The ASIC or the FPGA. It's implementing this rolling boxcar average. They call it.
Okay.
And and it's effective technique, and even the cheapest scopes, even the $200 scopes
Right.
have this.
You get free cleaner quote unquote signals, right?
Yes, yeah, exactly. So if your waveform looks noisy, in quote marks, I've done 2 videos on that of why digital scopes look noisy. If you don't know, there are technical reasons behind that, and compared to an old school analog scope, the answer is they aren't. They aren't inherently noisier. It's just
Right. It's just you're
something else is
seeing more of
going
it, or the sampling errors or something. Yeah.
Yep. Anyway, you have to watch my videos to understand that. And like they have this brilliant feature in there, and it's just Rigol don't have
gone.
it. On the new scopes is gone. It's gone. It's unbelievable.
These things happen. Oh man. Can you imagine?
So if you know the story behind that, please.
Yeah,
let
it's
us
like
know.
the man. Can you imagine like just getting that wrong? It's like I get boards wrong sometimes, right? You get boards wrong
of course.
sometimes. There ain't no bodging a chip.
Has anyone out there gotten a mask wrong? Have they goofed it?
Oh yeah.
Jerry Ellsworth, I think. She told the story about how when she was working at that toy company, she told the story about how she wanted to skip the country because like she was in China or Singapore or somewhere. She was working on this toy chip, and it was like her first ever ASIC. Like she had no idea what she was doing, but she thought she'd have a go anyway, right? And and the chip, she designed the ASIC for the Commodore 64, the all-in-one chip, and the chip came back and it didn't work. And it was like, and she seriously thought about skipping the country. It's a hilarious story. We might have to link it in.
Yeah.
It was on her first episode.
It was the first one? Okay, I was wondering because we've had Jerry on like 4 times, 5 times.
Right. Yeah. And she wanted to skip the country. But then she thought, no, look, I'll have a last crack at this. And she figured out that there was some unused pin on the chip and she could put it into some weird ass boot mode that would overcome this problem, and she was able to hack it with just like a pin lift or something. So she lifted a pin and tied in a thing and boom, fixed it. And whoo, it's like, she figured out this way to overcome a silicon, actually goofing up the silicon.
Yep.
So, but that was really lucky.
Yeah.
That was like, oh boy. Yep.
Yeah.
So if anyone out there has screwed up a huge ASIC like that, let us know.
I don't know.
Because there's no way they could have forgotten. Yeah, would you admit it? Yeah, exactly.
Yeah.
So anyway, yep. Speaking of
episode 35, episode 35.
35. There you go.
Yeah.
Okay. Speaking of goofs, the U.S. Navy goofed big time.
Yeah.
And I was talking to Chris about this before the show, and I'm surprised it got this far.
I am not surprised you got this far.
What?
I'm not surprised you got this far.
You're not surprised? Well, I am, having worked in the Navy, having worked in the military and the Navy industry. I didn't work in the Navy, but I worked, as a contractor for the Navy. And the headline is, the US Navy will replace its touchscreen controls with mechanical ones on its destroyers.
Yeah.
Oops.
UI problems.
UI problems. Apparently there was a collision in 2017, and they've done the study, to find out what the heck happened. Was it a Liberian oil tanker or something? The USS John McCain actually collided with a Liberian oil tanker. And they haven't read the whole thing, but it basically, it killed 10 sailors, right? This was a serious, serious damn collision. So they investigated this to the hilt, and it looks like they found that the touchscreens that they were using to actually control the ship, right, actually steer the ship, they just, it somehow goofed it.
I'm going to step outside of reality for a while here, since this is a serious thing, and I'm going to talk about the Avengers, because on the Avengers they also have a ship that has a bunch of touchscreens too, and then
I've seen that, yes,
and then everything goes dark, and I just always wonder, like, okay, say you were going to have your redundant power system needs are just like amplified, aren't they? Because now all of your touchscreen controllers have to be bulletproof. All of your power systems have to be bulletproof, everything else. And, in the movie at least, they're like, oh no, the power's gone. And then they're still sitting there tapping the screen, tap, tap, tap. Oh, there's all this.
The screen.
It's like,
exactly.
And then like, I don't know, blue screen of death is a thing, like.
Yeah, right.
Like what operating system are these things running? Like, I don't know.
I guarantee these are running a version of Windows. Guarantee
Windows CE.
I don't know about that, but they'd be running a variation of that, I'm sure.
Yeah.
Yep. Oh boy, that's just No, it's not good. It's like the planes that have fly-by-wire now instead of the cables.
Yeah.
There is a reason. There is a very good reason why Air Force One, spared no expense, is still a 747. Because why? Because it uses full manual cable controls. There can be they can fly through some nuclear blast EMP thing or whatever, takes out every computer on that plane, every piece of electronics on that plane, they can still land that thing, right? Because they've got the manual controls which go through cables right through to the back of the plane. They go to the ailerons, they go to the flaps, these manual controls. They can still land it.
I don't know. Like, I feel like some of it is, so we're moving obviously into we're in an age where like a lot of things are drive-by-wire, right? Even cars these days are, and all the car people are probably screaming at their third radios right now
throttle
too.
Does not, the actual throttle does not have a cable which goes to a little thing which opens the valve.
Right, exactly.
Right, it's... But they still make it feel like that's the case, right? So they actually put these artificial resistance things in the pedal to make it feel like the old school pedal.
Yeah. I mean, and like there are benefits to doing some of these things, right? The benefits are, you can have greater control, greater monitoring of stuff like that, like just having
737 Max.
Well, yeah, I mean, sure. But
right. Yep.
But I just mean that like so thinking about maybe not braking, but like, more instrumentation around a braking type thing in a car, right? You can have ABS type stuff and
of course.
You can have other things in there instead of just having a pedal that ties to the, pneumatics that clamp down on a disc brake or whatever.
Yep.
But
you can
complexity
still
in general
have that
is going
plus
up, right?
Those automated ones. You can still have those if you engineer it right. You can still have the automated ones do their business with the manual cable controls.
Yeah.
So
I mean, we're standing way outside our usual area here, but it is interesting as more things. Like everything has a touch screen these days. Everything is controlled by wire, that kind of thing, and it's just. If there's not money to continually test reliability, and in this case, it sounds like it's more even of like a human factors UI type thing as well. If you don't have like each link just completely bulletproof, like I don't know how it works as a system level, right? It's like you can't trust every link in the chain then, and then something's going to break.
Well, I don't know what happened with this touchscreen system, but I'm surprised that they got this through. I'm surprised somebody approved this.
Oh, yeah, so you mentioned this is your Navy experience.
They're really old school.
So
this is my Navy experience talking. It's like, they love their manual controls. I kid you not, I worked for like a month on a Switch.
Wow.
One Switch. Like, I'm not kidding, right? It had to be the right feel switch, sourcing this switch, actually building it into a test platform so that then it can go to a panel of people so that they can play with the switch and see that it has the right tactile feel, that the actual LED lit up bright enough under various conditions, like the backlit thing. Was it even LED back then? It may not have been. It might have been bulb still. Yeah. Anyway, they were very particular about, the look and feel of that switch, right? And it was like, it had to be the right way. That they just didn't accept it otherwise, It just had to be, perfect. Otherwise, they wouldn't have accepted some touch switch. It just, it just wasn't going to happen.
Interesting.
So,
but like, is it
anyway,
the, this is at a much bigger level though too. So if like everything's changing, you know how that goes. Like if like a committee of people are like, well, we're just changing this one thing, we need approval on this one thing. But if you're like, we're going to rip out the entire bridge and do it completely different, that could be very, that could be more drastic changes, I think.
Anyway, I am looking at a photo of this. Presumably, it's the console under question, and they do have manual controls below the screen. There's like these big lever things. I actually presume they're for like the throttle or something like that to, change the blade speed or whatever, blade angle, blade speed, and that sort of stuff. And
it says it's a different ship though. USS Truxton. Yeah.
Oh, okay, right.
Yeah.
Okay.
I'm guessing they're not going to show the bridge of the John McCain.
Of the one under question.
Yeah, that's a pretty big.
Anyway, they're changing back. They went bugger this. Like it's not the sole reason for the accident, but it contributed to it. So they're going well. Yep. Let's go back.
Yeah. Yep.
I don't blame them. That's just It's just
that's tough. I mean,
screen.
Working on interface projects. I've got one coming up that I'm working on. It's there's a lot of, I think it just enters another realm too, right? It's like, humans react very specifically to their graphical interface. Obviously everybody has an iPhone or a smartphone these days too. So there's there's new conventions that people are used to. And, you have to kind of play along with those human factors and make sure you're doing the right thing.
So can we go back to Rygol for a second?
Sure.
It's about user interface. Have you looked at the modern Rygols?
No, I haven't seen any of them.
Just call up just Google, Rygol 5000 series, or I don't know.
Sure.
And just look at the front panels of these things, or what's another? Is it no, it's not the Siglet one, but anyway, some brands just look like O1 or something like that.
Uh-huh.
If you just look at them, they just look so I think it's the Rygol that famously had 5 different fonts on the front panel. I think we've talked about this before, right?
No, this is the same friend who told me about this Rygol today. He said that he watched a video where you complained about reverse italics for 10 minutes.
Yes, right. Yeah, they had these reverse italics and and it's
Dave,
just a dog's breakfast.
Just let it go, man. Just let it go.
No, I can't let it go because we're talking about user interfaces, right? And how people expect certain things. And if you told me, explain what's wrong with the scope and why a Keysight one looks much better and much more professional, I'd have a hard time explaining it. It's just lots of subtle cues.
Yeah, but some of it is just your expectations.
Fonts, the color,
it's your expectations, though, too. It's what you've known
Sure.
for a long time.
There's nothing wrong. What's wrong with expectations? They've been built up over decades and decades of,
Well, it doesn't mean it's wrong. It just means that you're not used to it,
True, but then when you go to analyze it, you go, aha, this is why my brain thinks this looks really amateurish, because it does use reverse italics and 5 different fonts and all these weird colors that don't match and all these, it's just,
Dave enters the design world.
We've talked about this. John Kenny from Keysight, right? He came on. He's one of the senior designers at Keysight, and a great 5-part series for anyone who I think it's 5 parts on my channel.
Mm-hmm.
I think it's at least 3 parts or something. And I just sit down with him in the lab and just talk about design in Keysight products, right? Agilent back in the HP. He used to work HP back in the day. He actually knew Bill and Ted, right? It's Bill and Ted.
Bill and Dave.
Bill and Ted's Excellent Adventure. Oh goodness.
Bill and
Apparently
Dave's...
they're making a new one.
Yeah, I'm
they're
not a
making
huge
a new
fan.
one. John Wick's going to be in it.
Yep.
Yep. I'm excited. Anyway, and he's talking about, I'm sure he talked about user interface design and how important it is and how they have teams that, select the right colors and the right styling and everything else. And you can tell companies that like Rygol, they just give it to whoever and it and they just don't care, and it shows. right? It really does show. You put them side by side, and you end up with the reverse italics and the 5 different fonts and all the colors and weird grouping and convoluted layout.
we got to get on
right?
something else here. We got to get.
No, why?
If I hear you talking
It's
about reverse
important.
italic for 10 minutes, I don't know, man.
You're the one who brought it up.
Yeah.
User interface.
Yeah.
Come
yeah.
on. It's
Reverse-
important.
Reverse
Why?
italics
Why is it not important?
I draw the line at reverse italics, Dave.
Why?
It's so I don't know. Like I don't care about it. I mean, like I don't care about like the look and feel really. I mean, like I don't look at test equipment
Well,
like you
there's
do.
a lot
I
of
guess.
people who do.
Yeah,
There's a lot of
right,
people
right,
who
right.
do, right?
Right.
And it can matter if you're designing a product. Seriously, if you're designing a product and it doesn't look professional, people won't treat it as a professional product. And that reason might be because you got some dummy like me to do the user interface, right? It's like, yeah, it's going to look amateur.
Sure.
So, yeah. Anyway, I know you don't care about the small details like this, but they're important. That's why I like discussing them. Matters.
Yeah.
All right, go on to your next topic. Fine. Fine. Go ahead.
I don't.
Come on. Make it good. Better be good and interesting. As
know,
interesting
I
as
know,
reverse
right?
italics.
Let's see. How can I segue this? You should send the scope back if you don't like it.
Well,
No?
you shouldn't buy it in the first place. You can obviously
You're right.
see
Right.
from the screenshot.
Right. You should send
know.
it back if you don't like it, unless you can't, because it's non-returnable. That was my segue.
Well done. Yes.
The
yes,
parts
golf,
that I've
yes.
talked about last week, or 2 weeks ago rather, I was like, I think I'm actually going to use different parts. And I went to go return them, and Dave and I were talking about it before the show too. It's like, yes, parts
Your
are actually
cheapest ones you bought because they were like rock bottom price. You want to return them.
right, because I figured out another solution, right, and I could talk about that later
Right.
too. But and then I went to go hit the return button, and yes, there is a return button on like a DigiKey, right? And then it's like, no, those are NCNR. It's like, oh,
What's NCNR?
non-cancelable, non-returnable. As soon as I hit the buy button, those were coming to me, no matter what. So
Isn't that default if you get them on tape?
no,
If you get them on cut tape, will
don't
they
think
accept
so, actually.
cut tape as a return? Really? I thought you could only return like full reels and stuff or
You know
full
what?
tubes.
I can check this real time actually because I have a DigiKey order out right now. But I think you can return tape. Maybe not. Maybe that's not right. But definitely reels you can. And
yeah, right.
yeah. So you think about if you're a CM and you overorder the number of parts, I think there's probably a restocking fee. But and
of
you got to pay
course.
handling
Yeah.
and stuff like that. But you can't
Yep.
if you buy a reel of components very easily can hit in the thousands of dollars. And then you sit
Easily.
in the stock.
Tens of thousands even.
Yeah.
Yeah.
And you don't want to sell it on the gray market. So it's you can basically just return it and that's kind of nice. Not everywhere, and obviously if it's marked NCNR you cannot, but that's nice for some things. So
Yep.
um,
It's just never occurred to me to actually return anything.
right. Well, you and I
Really?
aren't ordering a lot of things that are
No.
like that. So okay, so
Well, sometimes I do pay thousands of dollars for one reel of components.
yeah,
Sure, and it's but I've actually used them. Like, if I did pay thousands of dollars, yes, I would be looking to get my money back.
right.
Either sell them on the grey market, as you said, or actually return them. So.
Yeah, right.
Yep.
So I'm on the site right now, and I can return. Let's see the 10 1.8 picofarad capacitors that I bought on my last order.
What?
I can return those for a credit of
Do it.
30
Do it
cents.
just
No, I
for
will not do it
kicks.
because it's the $7.50 return shipping. So I will not be doing that. But I could.
So it costs more to ship them back than it
yeah,
does
it
to
would.
keep
Yeah,
them.
right.
Yeah.
And I think
Right.
that's logistically that makes a lot
Of
of
course.
sense. But
Yeah, it does.
yeah. So it turns out you can.
That's great. All right.
Didn't know that. But we were also talking about, because I've got a bigger build coming up with in a couple, well, as soon as I get the parts. But we were talking about when you put in orders at lead time, and if I get a 16-week lead time on something, I need to get in line for those parts. And I'm not 100% on this, but I think you don't necessarily have to take delivery on all those parts. You at least need to get in line, right? So if I want parts,
Right.
I need a forecast for 16 weeks from now that like I'm going to be doing a build. But in the event I don't do the build, it's possible
You're not
cancel
forced
them.
to pay.
Yeah, right.
Right.
And so I don't think that it would be a smart idea to like go and order all the parts, because at some point they're gonna be like, okay, well, give us some money before we're gonna put you in line. But
Yeah.
but like from a risk mitigation kind of standpoint, like getting an order in, I've pushed for that before, where it's like, no, well, especially if there's something that's super long lead time, it's like I'm definitely gonna need that. I'll at least put an order in and then see what happens. It's always worked out that I've used the parts, but I think you don't have to take delivery for all of them. So TBD on that one.
Right.
So
Okay. I don't think I've ever done that. Maybe maybe the company purchasing people have, or something like that. But I don't recall ever having personally done that.
yeah,
I think I paid up front. Like I've ordered stuff that's like 30 weeks lead time.
yeah, right. It hurts.
Back in the day,
Oh,
it
it
was
still
common.
happens. It still happens.
Yeah, yeah.
Yeah, it's tough.
But we're so used to multiple source parts these days. It's like we're really spoilt for choice.
Like,
It's nuts.
what do you mean?
I mean, when you actually design something, there's usually some sort of alternative. If you're smart, you'll try and design your product around something that has multiple sources, or if you can't, at least it's in stock from multiple suppliers. So unless Murphy steps in and all of a sudden when you go to buy it, oops, all the stock in 5 different locations is all sucked up at once.
Right.
Then generally you're able to get it. There's not too many people these days that are designing a product and then waiting 20 weeks for the parts. Like not in the small side of things. In the larger end of
I guess
yes.
I guess that's right. Yeah. Usually people aren't waiting 30 weeks for a sample or the
Yep.
5.
No, that's right.
A 5 off cut
Yeah,
from the
no.
reel. Yeah, I think you're right about that. But from then a reel
with the lean manufacturing, these everyone wants some. Everyone's used to getting something now. They get their boards turned in less than a week. They get everything. They order their parts from DigiKey and Mouser, and they do it. You can design and build something in a week.
Yeah.
Right?
Yep.
Like waiting 20, 30 weeks is just nobody does that these days.
Right. Yeah, well,
So,
the thing that I always wonder about is people that like, there's like some really funky variants of like certain MCUs where it's like, oh, well,
yeah.
we want,
Yep.
we have to have the floating point unit, but we need the 64,
Yeah, and that's
megs
not
or
in
whatever.
stock anywhere. It's like,
right.
but
Well,
I
they don't
need,
even
I
do it
know I
unless it's
need that one.
bespoke, like it's just like
Right,
they have to do
right.
a fab spin they have to do a wafer start for it. It's like those are the ones where like people then are you add an external memory on a dev board or whatever it is, but that's disruptive to a development
As
process.
I said, but as I said, that's only going to be in the reasonably big end of town.
Yeah, I think you're right.
Your average midnight engineer or small company is just not going to do that. They're
Right.
going to find a different way to do it.
Yeah, I think you're right.
Yep.
Yeah. If you're digging into the spec sheet or the the ordering spec part of the data sheet, and you're like, no, I have to have this part. It's like, yeah, you're gonna hurt for that one if it's not actually a stock component.
Yeah, no,
anyway.
there's almost always alternatives to this. Yeah, if I was going for a micro and look, they do make this part, but nobody in the world has stock, and it's like, they're going to have to do a fab run for it. There's no way I'm going to design that into my product.
Right,
It's like,
right.
I would rather take the pain of switching to a different brand micro than actually waiting for that part.
Yeah. Yep.
So, yeah.
Speaking of micros, there was a article about it was inspired by your video on the 3-cent microcontroller.
Yes,
but
it was.
Then
It's actually Tim who's on the forum.
Oh, great. Okay. And so this was talking about
as I found out,
other low-cost micros and stuff like that.
He basically did a shootout of sub 10-cent micros and came up with this nice little chart. I hadn't heard of most of these manufacturers.
Yeah.
Right? It's a really great article, and there's a PDF version. Let me download it. The terrible 3-cent microcontroller comparison chart. Let's have a look at some of the company names. See if you recognise them. Hands up. Let's play bingo. Pull up.
Pull up.
Pull up.
Yeah. Pull up? It's like pull up.
Duke.
Paduke is the 3-set
heard
micro.
of Paduke
Yeah.
because it's a 3-set micro I've done a video on. Bojiangjing Industrial. Right.
This is going to be a terrible mangling from Dave. Yeah,
It's
and
a
me too, to
terrible
be honest.
mangling.
Yeah.
Oh, they've got the Y Spring Tech. Yeah, okay.
Eastspring.
East Soft Micro. These are all China or Taiwan, by the way. And Holtec, you might have heard of Holtec. So
Yeah.
Holtec's very common in they make chipsets for multimeters, and they make microcontrollers. We're using a Holtec part in the micro supply, actually.
Oh, yeah.
Not a micro, but they make an LCD controller.
Oh, okay. Okay.
So we're actually using that. It was one of the few LCD controllers. That's one of the things where, like, finding an alternative would have been hard. This Holtec one actually did the business and did it for a decent price. And there was nothing else.
Yeah, right.
There was nothing else out there that could match it for the price, not even close, I think. And it was like, yeah, we had to use that Holtec part.
Yep.
And anyway, yeah, there's all these different manufacturers. Great table, and but the Paduke one, they've now reverse engineered. Yeah, we mentioned this the other week. They've reverse engineered it. They've got now an open source compiler for it. There's an open source programmer.
Yep. And it was the
It's the
SDCC
only one of the lot.
It was the compiler. Yeah.
SDCC.
For those of you
compiler,
playing at home.
which now supports. Yep. And yeah, anyway, it's a great article comparing these,
Yeah.
and and all the different pros and cons of them.
There
it's great. Yeah, these
were you the
10-cent
one telling me
micros.
about the company that makes ST Micro compatible parts? Was that you or someone else?
Don't think that was me.
I think that is. No, which one is it?
They make ST compatible.
It's like it's
Yeah, what?
register
Yeah, but
compatible.
ST, it's registered like as in an ST ARM. Are we talking about like
Yeah.
an ST32 or something?
Yeah.
Really, they make a full register compatible version.
Yep.
Wow.
I think
Because if people don't know, right, you can't just buy an ARM chip from one manufacturer and then move to the ARM chip of, like, you can't just buy an ST ARM micro and then move to an Atmel ARM micro.
Right.
You just can't do it.
You gotta remap
they're
all the
physically
peripherals
different
and-
implements.
Yeah.
All the peripherals, all the registers, they're all different.
Yeah.
Right? So, yeah. Yes, your code, your base code will still work, right? You can just import that, but all your register settings and all your peripheral setups, your clocks, your timers, your UARTs, your ADCs, and all that, all these external peripherals, they're all custom for each individual manufacturer, which is a shame, but that's the way it is. So you're saying there's someone fully compatible?
I was in the wrong. Let me see if I can find it. I was in the supervisors thing.
You're in
Holtec.
the
I'm on
deepest,
LCSC.
darkest alley of Shenzhen, were you?
Well,
And somebody
no,
in a
this is
trench
just
coat came out and go, psst, buddy,
LCSC.
hey,
Yeah.
we
Well,
got some.
I think the reason this came up is so after looking at the parts that I end up buying and not buying, well, not wanting them, and then realizing I'm keeping them, I ended up going on. I was on LCSC and I was just looking at parts there, and there was a 35-cent STM32F030 part on there, and then like 15 cents for like a 433 megahertz receiver, and a 15 cents for a transmitter, and so it's like,
Wow.
yeah, that's real cheap.
Wow.
So that's
Yeah.
my current playing.
All right.
And we don't.
And it's a compatible part. It's not a genuine.
These are
Because they do
these-
sell genuine ones as well.
That's right. No, this is genuine. This is a genuine.
Oh, okay.
Yeah.
Right. Oh, wow.
Yeah.
And this is coming from a catalog supplier, because they are essentially a catalog supplier, right?
Yes.
Which is generally not the cheapest way to get a part. Yet they're still so dirt cheap.
Yeah.
Wow.
So it's 1/5 the price of the equivalent part at DigiKey is $1.50
Yep.
for the same quantity.
Yep.
So like
You did hear about LCSC, didn't you? I don't know if we mentioned it on the show.
I don't know.
Somebody busted them. They did a video tour or a photo tour of their production facility.
Oh, okay.
As in their pick and place, where they pick and place, as in they're picking, the stuff from the shelves and all that sort of stuff.
Okay.
And they were using one of those wireless anti-static wrist straps.
Yeah.
So I actually contacted them and said, hey, you might want to watch my video about that. And they came back and said, Oh. Yeah. Oops. Sorry,
all right.
we'll fix that.
Yeah.
So, yeah, ESD was precautions and LCSC were kind of out the window. So,
Yeah.
but they've fixed that now, I think.
That's good.
Yeah. They said they would.
Yeah.
So,
So I figured
Anyway, I
out
thought that was hilarious.
the name of it's Giga Device. That's who does the that's the
Giga device.
Yeah, so if you look at the part numbers, that's where it really becomes obvious, right? So if you look at STM32 normally would be, so here's an example part, STM32 F103 C8T6, right? So that's the C8 package.
That's the name of the
T6.
company.
No, that's the manufacturer part number. GD or that's
Yeah, but no, sorry.
yeah. What? Our wires are crossed
Giga
here.
Device Semicon is the name of the company in Beijing.
That's right. Yeah.
Giga Device. Wow. And
Okay,
they make
so STM32 F103 C826. The Giga Device part is GD32
GD in front
F103
instead of
exactly.
STM. Yeah.
And so like they're after STM, they basically completely replicated it. I don't understand in the modern
Wow.
world. Like obviously this happens with 74 series parts, right? It's just like that's all
Yeah,
out
of
there.
course. Yeah.
But this is
Yeah.
something different, and these are dirt cheap.
And there's a lot of effort that goes into that too.
Yeah.
Like to actually copy a chip at the register level. That
Yeah. Yeah. So
Wow.
interesting. I don't know, like the cost, like the STM32 parts are pretty cheap
Are
on there
they?
too. So
Are companies like this actually paying the ARM fee?
yeah, I don't know.
Or are they just stealing that as well?
Yeah.
Like, are they just like,
Here's the real question.
Wow.
Would you put this in a product? Because I don't think I would. I'd rather just pay right now.
I wouldn't. I would definitely pay the genuine.
Yeah.
Yep. If I was making 1 million greeting cards or something, and it didn't matter, of
And
course.
you're using a STM32 for that, of course, because why wouldn't you?
Right. Yeah. Well. Yeah. Right. It should be using the 3 cent micro, but
Right.
Yeah. No, I wouldn't put it into any serious product. If it was non-serious, and I just needed. If I was just doing something for, something for fun, like I was designing the world's largest LED array or something like that, and I just needed, 1,000 chips to actually do this, then yeah, I would, and I had to do something simple and easy, yeah, I would use something like this, but otherwise, no.
Right. So this is actually not new, apparently. So I just found a article from Dangerous Prototypes from back in January 2018. So this is obviously not new. And then it's linked over to a comparison. So we'll have that link in our show notes too, just for the...
Yeah. Okay, so they've got to do... How deep do they go into the comparison?
Solderability, Blinken LED, UART, and SpyMaster. So comparing all that stuff.
Okay, right. So they just some basic...
I mean, it's still something though, like actually putting it on a board.
Oh yeah, no,
and
of
doing
course,
it, so.
yeah. No, you've got to get the oscillator configurations working. You've got to get the I/O configurations working. You've got to get
We may have even brought this up before too. Who God knows?
Oh, really?
Yeah,
Okay.
well, because Zeptobars
Right.
did a shoot of it too. So,
right. They actually.
and usually when Zeptobars do something,
decapped them,
we
did they?
mention it. So,
And is it a physical copy or is it just a register? Actual reverse engineering copies.
I
Because
cannot
surely
tell.
they don't get access to the masks
Yeah,
to
yeah.
actually copy the masks,
Yeah.
right? So I'm sure they're different.
yeah. Well,
It's just remarkable. But the Chinese market is so big.
right, especially
it
and
pays
the
these companies to do
STM32
it.
is like in everything. Like they really.
It's in
have
everything.
huge
It's
inter-
the de facto standard.
Yeah, exactly.
Yeah. Yeah. It's sort of it's like the ARM market like five years ago,
Mm-hmm.
like 7 years, like the ARM market was so flooded. It was like you didn't know who to choose. These days it's like you're probably going to use the STM32, right? That's kind of like if you're coming in and going, I need to use an ARM chip, that's probably the one you're going to choose just because of like everyone else is using it kind of thing, right?
Yeah, yeah.
It's like, yeah.
I mean, there's a lot of stuff out there. Supply is obviously pretty high, so that helps. Obviously, you have 2 vendors
Yeah.
now, so yeah. It's,
wow.
we'll have to-
Well, that could work at a pinch, right? If you couldn't get the part, I don't know,
yeah.
somebody came along and bought up all the STM32s and you were going, shit, I need to ship my Kickstarter.
Yep.
It's like, well, you would have a go. Because the problem with this is that you can test it, right? We've talked about this on the Amp Hour before. You can thoroughly test something. Like, it is not a risk to use this unless Well, no, even then, no. There is almost, there's practically
versus
zero
Dave
risk
versus
in
Dave.
doing this. Yeah, Dave versus Spy versus Spy. If you thoroughly test this, like you get this sucker in the thermal chamber, you test it over its thermal performance limits and voltage rail performance limits and clock oscillator limits and every other variation limit you can think of, you can be 100% sure that this chip's going to perform in your product. Mm-hmm. So there's no problem there. So if I wouldn't necessarily be against using this in my product, but I wouldn't design it in from the start, right? I'd be designing in the ST one, and then only in a pinch would I think about using this one. But you certainly can.
Yeah.
It's just a matter of testing, says the guy who comes from the test engineering background, right? It's like, this was this is what I did every day, right? It's just, test stuff over thermal and other limits, even vibration and shock and all sorts of stuff, right? To make sure it all worked.
Yeah,
And
I don't know. I don't know if I would design something like this into my circuit, And by that, I mean, I don't know if I would.
I wouldn't design it.
I don't know if I'd put a microcontroller in my circuit, Dave. That's what I was really saying. You just really can't trust
micro in at all.
You can't control. You can't trust microcontrollers these days.
No, dodgy as.
Yeah. We should use that as our excuse to leave.
Oh, wait,
my
10 minutes
silliness.
past. Yeah. Yep.
I will be reporting from the road next week with the Mighty Ohm and maybe Alvaro and a bunch of weirdos from Chaos Camp. So, looking forward to that.
You'll be in Germany.
Yeah.
And you're going to Iceland or something as well, are you, or somewhere?
Yep. Stopping over there too. So that's
why,
just because
why are you going to Iceland?
Because the cheap airlines fly through there. So.
Oh right. Okay. Are you actually going to see some sights there?
Yeah. So this is like a 24-hour layover.
Right. Oh, is that all?
Yeah.
Geez, you can't see much in 24 hours, dude. Come on, it's Iceland.
Not a big country, Dave.
Yeah, but come on.
If there's any Iceland
I've always
listeners,
wanted to go there.
Jeff and I will be there. Let us know.
All right.
Catch you next time.
Catch you next time.
No, catch you next time. See ya. Why do you always get to see catch you next time?